Over the last 3 months, we dropped 12 episodes of AI Toy to Tools video podcast series. We talk to AI experts in various domains ranging from automotive, industrial, to medical and chip designs. Our goal was to find answers to the following 2 questions. First, how is AI developed, tailored, and optimized as real-world tools? Second, how are experts in specific sectors using AI? Today, we have invited 4 guests on this concluding panel to discuss what we've learned about the domain-specific AI. Let me introduce each person on this panel. We've got Bryan Reimer. Hi, Bryan.
Hi, Junko. Good morning.
Good morning. He is a research scientist, MIT. And we also have Mauricio Munoz. Hi, Mauricio.
Hey. Hi, Chuck. Nice to see you again.
Yeah, thank you. So he is a senior research engineer at AI Sweden. And then we've got Marc Dupaquier, managing director, AI solutions at ST. Hi, Marc.
Hello, Junko. How are you?
Very good. And last, Ali Ors. He is the AI strategist and technologist at NXP Semiconductors. Hi, Ali.
Hi, Junko. Hi, everyone.
Great. All right. I'm going to just pick 1 or 2 people to answer the first question that I have. This is the kind of big questions, but what are the keys to making AI deployment successful in each domain?
I think the key is moving beyond our focus on the technology. So great, we have a better algorithm, but is that algorithm transparent, free of reasonable biases, acceptable to the consumer or business to business applications, protecting the privacy? So if I look at the areas of AI looking forward, I think let's call it the soft side of AI, or the human side of AI is going to become just as important as the technological enhancement of algorithms. And that is not to downplay our continued evolution of AI and algorithm development. But the real value proposition is not AI to replace humankind. It is really AI to amplify human expertise.
Bryan, it sounds like you're really talking about shifting from evaluation based on benchmarking, which I think we barely have working now, to a much more qualitative kind of evaluation.
Yeah.
Am I getting that right? And can we do that?
Absolutely, Ron. Now, I think it's not can we do it, it's we must do it, and how fast can we do it? And I think the organizations that truly do it effectively are going to be the real winners here. So, how do we develop systems that support you and me, that we feel like we can trust as friends, as quite frankly, electronic friends as part of our lives? How businesses trust other organizations to manage data transparently? How governments allow us to evolve technologies with reasonable assumptions around biases, because we can't get rid of it all. We have limitations in what we can engineer and what we can build, but we have to be transparent in what we can do. And it's the softer side that's really going to dominate the growth areas of AI. That is not to say that I see any of the spending on the advancements of algorithms, the advancements of data centers to decline. I think the reality is we need to increase our spending on human factors, psychology, societal questions at large, and how we work to move the ecosystem of AI from one based upon technology alone, or predominantly, to one based upon human-centered engineering at its finest. And I think that is the challenge for AI looking forward.
This is about what are common threads among different domains. Ali has worked within NXP, both applying AI for automotive, but also applying AI for medical and industrial. So maybe you would be the perfect person to answer.
Sure. So from what we've been exposed to and what we've seen our customers developing, there's a lot of commonality. And I go back to what Bryan kind of mentioned of from the technology perspective, there's a lot of commonality. You look at even the fundamental models of what you're running, the hardware that is required sometimes in the pure processing sense carries a lot of commonality, and that sometimes forces people to assume that, oh, well, as long as I have this piece of silicon, this piece of hardware, this box, I can do anything. I just can apply it to all different sorts of domains. There's some truth to that, but the human factors engineering aspect is critical. The availability of data specific to that domain becomes critical. A lot of us have seen, how good AI is at detecting cats and dogs, but really, does that apply to how well it handles, detecting certain, markers in a gene, even from visual perspective, or putting together various diagnostic aspects of human biology to say, well, this might be what's causing discomfort to this patient. Our conversation has been around applying AI into healthcare.
Yeah.
And while I see a lot of commonality in other domains, even from the mobile space, in leveraging technologies like ChatGPT, yes, you can apply it, but you need certain specifics around the human engineering perspective. The deployment into that specific domain requires both specialized data. So beyond just fine tuning to actually make it a reality and practical. And also, it needs sometimes a step back and look at how we're applying it. We're also seeing other technologies that are not about directly the patient care itself, or applied to the patient and diagnosing the patient, but can augment the capability of the practitioner. So you have the technologies of new machines are being developed in a lot of domains where you have limited expertise, or you have a lack of trained expertise. How do you bring the workforce up level them, leveraging AI? How do you use the technology so that the practitioner can use this technology better, more effectively, and the end result is better patient care? But it's not always the way patient care is thought of directly applying it to the patient. It's actually an indirect way of providing that result. And we've seen it now, going from automotive, where the big story was autonomous driving, that was applied in some form of fashion to robotics and still some level of mobility. But all of those learnings also apply to medical robots potentially, and medical devices. And then the human factor kicks in a lot more in certain domains versus others. And you do need specialization. And from my perspective, what I see is usually the availability of domain specific data towards the end use is extremely critical in making successful deployments.
Yeah. All right. Yeah, this is really a rich area because, as you say, it's not, applying one thing and you can use it commonly in every specific domain. I'm going to ask the same question to Mark. You know, I think ST, when we talked about the use of AI in industrial applications, you made it very clear that where ST is focused on is not necessarily the transformer. So tell us that where are the common threads among different domains?
Well, I think a lot of that has been covered already. So first, what we do play into is really what we call edge AI. So I understand there is a lot of buzz around AI. Most of the buzz today is really around the world of LLMs and all that. That's fine. That's not where we play. We understand it. It's literally not where we play. And where we play is really more into this approach of edge AI. The point was really, what does it take to make not humans, as a matter of fact, but machines do slightly better jobs, and that really was about improving information about the health of a machine, of a pump, of whatever, this kind of approach. So and this was going with a set of models. Obviously, whatever problem you are trying to solve, your data has to be specific to this problem. There is no common set of data that you can do, and even in vision related use cases, it's if I want to have a robot mowing machine, that data set has to be taken at 4 inches from the ground, not whatever data set you have for a pizza or whatever is completely useless. Obviously, we spend a lot of time with our clients, which is a little bit linked to what Bryan said. And we almost say it, but in a more direct way, which is it's not because you can do everything that you should be doing anything. It's so whatever you do has to bring a value to either the user of the machine, to the user of the service, and this value has to be delivered at a level of affordability that actually is useful to everyone.
Yeah, right. I think that actually flows into that where AI diverges, right? And I think this would be the perfect question for me to ask Mauricio. Mauricio, we talked about you kind of you are the researcher and you have also worked in the automotive area, but you looking at AI from the broader angle. So tell us a little bit about where things diverge.
Where things diverge. So I guess you could interpret that in many different ways. I think there's this understanding at the moment that, yes, there's a big push for, I guess, general intelligence, right? I mean, this is essentially the trend that we've been seeing for the past 5 years or so. And we're continuing to push towards that. But I think, as we've mentioned already here, I think one of the very key factors that is sort of missing here is we still require very high quality domain data to be able to really pull things off that are essentially domain specific, right? So you can really only get so general before you really need to start to get specific again, at least in my opinion. And we basically need that data to be able to really fine tune these things down to something that is actually usable, right? And so I think this is where sort of like things diverge. I mean, there's many different opinions about where things are going, right? Even this discussion on general intelligence and, are we going to have a model that's going to be able to do it all basically just, off the shelf? Many different opinions out there also in terms of the safety of these things. Is it worth to, should we set up institutions to actually crack down on the safety from a third party angle? Should we continue to basically self-regulate? What is the government's involvement in all of this? I mean, these are hugely, disparate, like very different angles, right? That we could look at this from. So I think rather than talk about where things diverging, I think you could basically assume everything is diverging, and there's actually fewer angles that are actually converging, right?
Yeah. No, that's yeah.
You mentioned, I guess everybody has mentioned divergence in terms of the data used for training. Is there also going to be divergence in the models? Or are we going to end up with a very small set of models, not a zoo, but maybe an aquarium, that can be trained to do pretty much anything we need? That's part A. Part B is, if we do need different models, is there any way of working back from the problem to be solved to the correct model? Or is it all just cut and dry?
I can start to jump in because we do spend a lot of time talking about it. So first, we have many different ways of solving a problem from an AI standpoint, and you can use many different models. Some might be better than some other, depending on the constraint that you have. One of the constraints, obviously, on edge AI is the cost of the device itself, so the BOM, and which kind of hardware you want to bring into it, the memory available, the energy that you would like to consume, and so on. So we do spend a lot of time trying to analyze it. As a matter of fact, we use generative AI to understand the different trends in terms of models. We just went through it, studied about 40,000 different AI papers analyzing different kind of models, just to understand what's going on here. And then we try to match with this. Why does it matter? Because the kind of model that you will be using will vary by business needs, possibly by industry. Obviously, safety is a factor, but there is more than that. Based on the data that you want to do, based on the level of service you want to provide, and so on. And eventually, once you do it, because you use different kind of models, you will need different kind of hardware. So eventually, we need more than one kind of acceleration. And and that's why we try to understand it, to understand where we need to invest in terms of acceleration, which kind of IP we need to acquire as well, which kind of memory needs to be available for the hardware device. Because at the end, whatever model you run, it will be running for the inference standpoint on the device, and that's where we play. So that's why we are very obsessed by this. So we look at the data and the use case. The use case goes to the data goes to the model, and the model goes to the hardware. So that's a chain that we're trying to understand. And what we see, obviously, is by industry, by use case, it varies widely.
And I'll build on that a little bit, Ron, is that I think we've seen over the last several months, years, a real accelerated investment in the back end side of AI, an explosive investment in GPUs and in new server facilities to enable Gen AI. And I think that many in the market are starting to appreciate the overinvestment potential here is real. I think as Marc is highlighting, edge computing, doing this on small chips on the edge is probably a lot more of the future than the big folks in Silicon Valley want to admit. Speed, efficiencies, smaller models, domain specific, all are words that to me resemble moving from big architectures and servers back to small and on the edge. This is really where we begin to hear in the news exceedingly frequently right now, the AI bubble. Is it going to burst? When is it going to burst? What's going to be left? In how to make AI useful, my book with Magnus Linkovitz, we really talk about AI being a balloon. And I think that the balloon is the technology, the bubble is the finances. When the finances explode, I think we're going to begin to see how much utility there is at the edge here. But I think at the end, we got to think about how this becomes optimized, how this begins to move closer to my hands and my fingertips. And I think we will. So not to say there's not going to be a lot of back-end componentry, but to me, the future comes back out to the device level. Now, that device may not have a screen in the old-fashioned way. It may be my watch. It may be something I'm not even thinking of today. And it could be an implantable or a robot roaming around my house. But I think the embodiment of AI will move from chatbot and Gen AI to something completely different. Where, we will look at Gen AI a decade from now and say, what were we doing back then? And I think that the edge world, for a lot of efficiency reasons, is going to evolve forward.
All right. I think Ali wanted to say something.
Yes, I mean, I think it's been covered in terms of the need for edge deployment. But even within that edge deployment, I think some kind of taking the analogy of just because AI can do it doesn't mean that you have to do it with AI. Just because you have LLMs can do it doesn't mean that you have to do it with an LLM, a CNN, so convolutional neural network, which has had a few more years to become more embedded friendly and optimized, is a solution. But even there, I'm going to contradict myself as well, just in what I'm about to say. Because an LLM can do it, or a vision language model can do it, yes, it requires more training and expertise and investment at the front end, as well as a lot more compute resources and memory resources when you deploy it. It does give a lot more flexibility once it's deployed as well. So what we're seeing in the market, yes, we have customers that are very focused on the bill of materials cost in actually deploying the most efficient piece of hardware that achieves the specific solution they need. So you have microcontrollers that can run AI even with acceleration. You put a CNN or even a classical machine learning algorithm on there, and you're happy. You might be sitting under $2-3 of processing cost. But you also have customers that are looking at it as more of a general purpose PLC, like a compute box that can go into industrial. Yes, today it might be doing things that a convolutional neural network with a few cameras can actually detect production deficiencies and maintenance issues, etc. But their goal is to keep expanding on that, and you're adding more capabilities in terms of understanding the scene, understanding the situation, leveraging a multimodal input both from audio, vision, and multiple sensor modalities into it. And you don't want to be creating new models every single time. You have this more general purpose, highly capable VLM or VLA that is used, and you can keep expanding your portfolio of use cases that you offer without changing the hardware.
You and Marc are both deeply involved in the back-end hardware. It seems like so far the concept I've been hearing is figure out how to do a fast matrix multiply, have a fast CPU to feed the multiplier and to clean up the results, and you're good. Are we going to see more specific kinds of hardware platforms as we see models diverging, or is that going to be the paradigm?
If you know exactly what you're trying to do, then you have the opportunity to create a highly specialized, customized piece of hardware that is the most efficient for that, smaller set of algorithms you're trying to run on, potentially. But if you have some, uncertainty in both what you're trying to do today and then what you think, how long this device is going to be in the market, in deployment, in the field, and you need to provide for flexibility in the compute that it's going to do, then you end up going towards architectures that are more flexible. Now we've seen this with when the whole point of a GPU came about. So you had CPUs that they were able to drive your display to a certain extent. So maybe I'm aging myself that you could have a CPU drive your display, but then you needed the more and more the graphics got sophisticated, you ended up needing a GPU. As your telecom algorithms got more sophisticated, you ended up needing a digital signal processor. You ended up putting DSPs onto these, onto the heterogeneous compute platforms. Similarly, we have a lot of deployments now with neural processing units, with tensor processing units, with dedicated AI accelerators. They make sense as you get more clarity in the types of algorithms you're trying to run for AI. But if you don't know what is coming down, usually when these algorithms come out, they end up running on a CPU or GPU because those are more flexible in terms of compute. And then there's a market need to run more efficiently, higher levels of parallelism and higher efficiency. Then you start getting into specialized architectures. It's always a bit of a balancing game. And as both Marc and I are on the silicon side, on the processor side, what we design doesn't get into, what we start designing today won't be in the market for 2-3 years. You need to really balance that flexibility that when it comes into market, the algorithms are going to have shifted already.
I'd like to offer maybe a bit of a contrarian view here that differs a bit from what we've heard. So, I mean, obviously, it's one thing to think about what's happening at the edge with basically consumer-facing technology, right? That's, I think, one side of the equation. But what I think we shouldn't forget is basically what is happening in the back end, right? In the back office of these, major corporations, right? So the closer that you get to actual frontier models, by definition, there are fewer of these because they are simply just much more expensive to create, right? So I do think, going back to your original question, Ron, that I think we do see some consolidation of not just specific models, but architecture choices in those models. That basically leads to, for example, better scaling properties and all these things. And this is a wonderful output of the research that's happened in the last couple of years. But in particular with like how this also affects the consumer at the end of the day is, I think, also something to consider in the sense that, for example, in this last year, we've seen really amazing progress in terms of really using the frontier models of frontier LLMs and similar and hybrid systems with LLMs for example, things in the natural sciences, right? For mathematics, right? So just to give you an example, material discovery, right? Or chemical compound discovery, right? So basically things that are automating the scientific process, right? From my side, as a research engineer in AI, right, I recently saw a paper that basically automated the discovery of neural network architectures, right, through essentially an agentic setup that just basically was a closed loop sort of thing that essentially recommends approaches, tests them out, and then iterates on this concept, right? And this ultimately ends up affecting the entire engineering process, right? To some degree by automating what's going on in the back office. So really frontier models in there, I think I said, the consolidation is one of the things that we can very clearly observe, and I would expect it to continue in this way.
Yeah.
So we're going to be simultaneously seeing the back office converging and the edge diverging.
Could be, yeah.
We're seeing this on the edge where there's a lot of very capable open source models that tend to be leveraged initially. And so, we adapt to that in terms of the types of models that we support on our hardware and the software enablement that we provide to be able to support those hardwares. I'm talking about things like Llama from Meta or Coin models from Alibaba, etc., that have a lot of capability, and people are using them because it's really prohibitive to try to create your own initially, at least. And as these models get better understood in the field by additional researchers, additional technologists, then we're seeing now companies that are saying, "Oh, that's great. Give me your benchmarks for this, but I'm doing my own thing." Anyways, and that is really accelerated in what we're seeing. Like, well, we saw that transform, that move in convolutional neural networks take a few years before companies came and said, that's great that there's all these open source publications and research, but I'm doing my own thing. Now with LLMs and generative AI and agentic AI, we're seeing companies coming in and saying, I'm doing my own thing. Now tell me how you can run my model more efficiently. I don't care about the open source pieces. And instead of a 3-4 year span of individual companies starting to do their own thing, even though we felt that it might be prohibitive in terms of investment, it's happening a lot faster within the year or so of being edge ready with some of these technologies.
Wow.
Junko, I think what I'm hearing here is that it is very much where there is no one size fits all solution, is that there are a lot of approaches, even going back to sometimes simple old regression will solve the problem, and quite frequently with a very low computational overhead. We've been investing so heavily on one flavor or one perspective, but yet the foundations are so strong across multiple perspectives. And I think that's where the balloon of AI, it's going to go up and down, is far different than the bubble of AI that is likely to burst. And I hate to use that language, but I think the more we can move the mindset to there is so many fundamentals spread across this ecosystem that are going to succeed, the more we can move that from the hyper overinvestment that's occurred, the better.
And there will be losers, right, Bryan?
Absolutely. There's going to be huge winners. There's going to be huge losers.
And it's that size of the loss that is scary in terms of the burst. But there will be winners in this as well.
Absolutely, and I think that's why I will separate the financial bubble from the technological balloon, because there are folks that are primed to be on the upswing who are thinking about the optimization of the system far greater. And this is exactly why I think that there is so much critique out there on big tech in California of how you're going to make money in Gen AI, being thrust at Meta, Alphabet, NVIDIA right now, is because there's no perspective on how do you create a ROI on some of the cash spending. Whereas there's lots of other organizations out there that are thinking about really investing in utility from the ground up in how we're going to create value for the consumer, how AI can evolve forward, that are going to be winners here that are right now just not in the prime of discussion as Wall Street worries about, quite frankly, hundreds of billions of dollars, if not $1 trillion bet.
Yeah. Well, speaking of the ROI, I'm kind of wondering if each person on this panel can share where you're expecting to see the biggest ROI when you deploy AI in your specific domain. Do you have any idea?
I'll drive in, Junko, because it's kind of easier for me from more the academic side. I think that as we begin to deploy AI more readily in various domains, we're going to come to full realization that the failures in our deployments in AI are rarely technical in nature. They're always about the human component. They're a human component in lack of specification. They're a human component in not understanding the use case. It is all about how we as humans are interacting with the system. So it's going to come back all around to the human. Leaders who unlearn as much as they relearn new models here and approaches to business are going to be the ones that are most successful, allowing their organizations to sandbox ideas, grow them small, and then scale quickly when they can figure out what works and why it works.
Yeah, and if I can jump in, we discuss ROI with our clients. Obviously, since we are providers of technology, The ROI eventually belongs to our customer who decides to implement the solution. And here it goes into two ways. One clearly is when I add, for example, a new chip that would be able to AI acceleration and a model and all that, is the extra cost bringing enough value so that either my clients, the end user clients, will be able to accept this or see the value here. And the debate is always like this, like, okay, there is $1 more into my bill of materials. How can I justify this into my cost? And then it goes into the differentiation of a product versus a more standard product with none of these capabilities. When the AI is applied to something which is like a toy, very, very little value, at the end, it's hard to justify. But when you bring something that is really valuable, like checking the attention of person in a car or improving the safety of a relatively dangerous device that you want to use, like a chainsaw or things like this, then it's fully justified. And already here, you have a return of investment because the business needs were there in the first place. The second level of trade-off is between AGI and AI, because basically you can do everything in a cloud. Now there is a number of workloads that make more sense to be done at the edge because it will cost less. So no one wants to pay the cost of the cloud, frankly, when they don't need to. So it's at the end, it's well, I will use AGI instead of AI because finally my product will cost less. This will be a more virtuous product as well because it will need less energy and so on. So it's clearly a two dimension we have when we discuss with our clients in terms of return of investment and whether this project makes sense or not for them.
Yeah. All right. This was not in the question, but I just wanted to ask that the some of the episodes that we run, our guests focused on, especially in the automotive field, that emerging significance of using end to end, and that has kind of become a fashionable thing in the automotive, and I don't know whether that's going to apply in the rest of the fields, but I'd like to actually bring in Mauricio to say a few words and how you look at the end to end. Is that going to solve all the problems with the data labeling and they make the whole process faster? What do you think?
Yeah. So I would say, I mean, there's never a silver bullet for anything, right? So everything has pros and cons, but it's interesting because there are actually very strong parallels to AI and machine learning development recently with this end-to-end discussion, in the sense that I was, at the beginning of the year, I was willing to bet that for the next 5 years, we would focus very strongly on so-called hybrid systems. So essentially LLMs interacting with other very knowledgeable bits and components of information, like, for example, physics models or verifiers, solvers, things like that. So things that we can inspect, that we know how they work, that basically gives the model essentially context in which to work, right? And this working back and forth between these components was really going to enable the next frontier. And we saw this for a while with, for example, things like math solvers, right? And for example, what DeepMind came out with, that you could really see it's the going back between these two things that is really giving you the advantage. However, as always, predictions really have to be taken with a pinch of salt, because this year also there was a news released that for the International Math Olympiads, both OpenAI and Google got away with gold medals with precisely end-to-end learning. So without any of these components, and they basically just learned an LLM end-to-end to be able to solve these things, which basically just destroyed my hypothesis, right? That we were going in that direction. So with that analogy in mind, I think I'm much more careful now to basically really say, how things are going to be or not. I think, from a systems development, I'm not entirely a friend of this mentality, because I think end-to-end learning really means you need a lot more data to really get it that going, right? Versus working with clearly identifiable subcomponents that you can individually test, that you can individually verify. And this has been, I guess, the traditional way to do engineering for so long now, that I don't know. It seems to me that we're inviting more future errors into the process by using this paradigm than really getting the benefits that are promised through it. But that's, I guess, just my personal opinion. I think for me, it's we have to basically wait and see. Again, if nobody tries it, then we'll never know, right?
Yeah. All right. Very good. What are the things that are still missing for us to pull off successful domain-specific AI? This could be hardware, software, tools, applications, or organizations, and the way people embrace AI.
I mean, we can always I can always revert back to availability of data and
Ah,
availability
that's
of
a good
data
one.
more openly. So I think there's a lot of open data, but in a lot of the initial successes around natural language processing and vision-based processing came from the fact that research organizations contributed to very large collection of data that was leveraged. Now, with LLMs, etc., there's of course this controversial aspect of any data that exists can be used with the copyrights, provided or not, and etc. But in the specific domains that NXP is active in, if you step outside of typical language and typical vision, you suddenly end up needing specific data for the healthcare discussion that we had. For anything in industrial, it becomes highly custom to that deployment. And I think Marc kind of alluded to this of with the robo lawnmower, just because you have picture of fields and grass doesn't mean that it's taken at the right angle, at the right setting, at the right illumination setting, so that your final product works. So this and we're seeing some movements in terms of much more capable synthetic data to try to solve some of these problems, which is great. And then the final validation always has to come from the actual deployment. So I think data is still somewhat of a control point in the successful deployment. Availability of data and the ability to collect data and simplifying the data science aspect of it is critical. And then we also don't really have standardization, and it's really hard to get into standardization into a domain like AI that is moving very fast. Places where standardization has really helped. It does slow down innovation at times, but it also creates a lot more capability and a lot easier deployment into the field. So I'm not a big fan of standardization, but I also see its benefits in wider
Yeah,
adoption usually as well.
that's good. Do you want to take that what's still missing question, Bryan?
Sure. I'm going to agree with Ali. A lot has to do with data. And I think, data is controlled not by corporations and not necessarily by individuals, as it may need to be, by government regulation. So in Europe, what AI can do is severely handicapped by GDPR and other regulations. In the US, maybe it's a little too free. In China, maybe it's a little too unknown. I'm just giving some caveats here. So I think if we want to accelerate forward here, we need to give the consumer a little more control of their data in all ecosystems. So much like I went into my credit card statement the other day and was able to look at who has my credit card, I need an app on who has my data. And if I'm in Europe and I want better healthcare decisions, I'm willing to give my data to A and B and C in ways that GDPR may never have allowed to. But you know what? I'm willing to contribute my data to be better. In the US, I'm willing to, well, maybe we default into a little more data sharing here in the US because that's the de facto we seem to be coming from. You know what? I want to be able to pull my data back from different brokers because, quite frankly, I'm not a big trusting there. I think we need to shift around the data stewardship side globally so that we can begin in certain climates to augment and perform better by having more, in other climates being able to pull things back in that ownership. Right now, there is a lot being scraped out there in the world, and there is a lot that's not being provided because of regulatory prevention and privacy restrictions. But in applications like healthcare, we are going to have to get beyond the privacy aspect. We're going to have to be all willing to submit a little more. And I think the Israelis, over time, in the control of the health system, there have illustrated that they can do things that the rest of the world can't do because they have the data. And quite frankly, the more we can broker that, I think the big real step forwards in quality of systems, quality of performance is going to go up, and probably mitigation of compute, because garbage in and garbage out still applies with even the best AI.
Mm-hmm.
That's a good point. What about you, Mauricio? I think
Yeah.
you're the one actually who brought up in your episode that the limitation with data is actually, for example, automotive industry. If each company is collecting a lot of data, why wouldn't we share that for the sake of safety, right?
Yeah, exactly, and that's what I would bring up now. So I would have two specific points, or two specific answers to this question. Number one is, I think we need a better, more stable validation and verification concept for a lot of these things. Something that basically, I said, I don't have an answer to now. I don't think really anyone does, but we need to really start to take this seriously, right? And even answer the question, what can't we even verify and validate, and are we okay with that? Yeah, I think that discussion needs to be had and had seriously, and that, of course, has many different shapes and in characters for each industry. But for sure, for certain, that needs to happen. And the second point is, I think we need to go back to the organizational level, right? I think we need to build industries that are AI ready from an organizational point of view, in the sense that large companies, as we've seen, struggle to keep up with the very fast pace of AI. It makes no sense to develop a project or develop a product that's going to be in production for 7 years or whatever, while by the time that finishes, it's already completely outdated, right? I think this is why startups nowadays that are working with AI are in a massive advantage to all these legacy institutions that simply, like I think I stated in my podcast, really can't differentiate an AI initiative from a software and engineering initiative. These are two very different things and should be treated as two very different things. So that definitely needs to happen. But aside from that, I mean, we need to build the organizational structures that enable large companies and large organizations to be quick and agile in this space, which includes collaboration between each other, between academia, between different sectors, to basically speed up this learning as fast as possible. Because if you are basically just a single player alone in this very big field, you're probably not going to make as much progress and move forward as if you were to collaborate even with your competitors. To be honest, on pre-competitive stuff, there is a lot of things there that are basically just left on the table, right?
Do you think we can identify the things that are pre-competitive and separate them from the things that are potentially competitive advantage?
Absolutely. I mean, it's one of the mission statements, actually, that what we do at AI Sweden, right? A little bit of a shameless self-promotion here, but it's precisely why organizations like this one exist, right? Is to identify these things, identify these technologies and methods from which everybody benefits. It's definitely possible, and I think we're proof of that. So, yeah.
Well,
All
I'll add to that, Ron, that as we identify, it's so fast moving that what we identify as a monetizable value add shifts and becomes commoditized very quickly. Like if you come up with a new algorithm, you might think it's highly differentiated, or you might come up with a solution for a given market that is highly differentiated. But in a few months or next week, somebody publishes something openly that totally destroys your value proposition and your business case. So it's exciting, but it's also extremely challenging.
So there's
Couldn't agree with
companies
you
out
more.
there using generative AI to undermine your proprietary advantage.
Of course, yeah.
Yeah. All right. Very good. Well, thanks everybody participating in this panel. We learned there's no one-fits-all AI model. We also learned that it's important to figure out where you apply AI, how you apply it, and who is it for. I think that was very well explained by Marc. But then at the end of the day, really the not only who has the data, as Bryan said, who would allow your data to be used by others, but also who has the access and how would, structurally speaking, not just one company doing the great things, but as an industry, how we would let that access to data available. I mean, that's something that we all have to think about. All right. Well, thank you very much for coming to the show. And I think we'd like to, maybe, given that things are moving so fast, maybe we should meet again next year. All right. Thank you so much.
Thank you, Junko.
Bye.
Thank you.
Bye.
Thanks,
Thank
everyone.
you.
Bye.
Bye.
Bye.